Okay, the situation here is we've got an equation and we've got to show that it's got a root between two values. Now this is an extremely simple method. Unfortunately, the exam board is amazingly prescriptive and strict about what it wants you to do. Okay, so please show all of the steps that I'm going to do. Don't try and take shortcuts in this method because they're just ridiculously strict about what they expect and rigid. Yeah, right. So first thing is this equation does not have naught on one side. Okay, you will get no marks unless you rearrange it to get 0 on one side. Okay, so we need to get naught here. So we have e to the x minus 2x minus 1 equals naught. However, you can also end up getting no marks unless you put f of x equals. The idea is that we have a function that we want to equal naught, and they want you to name that function f of x. So solutions in which the f of x doesn't appear and you do everything else right can get no marks. Okay. The other thing I should have said, don't trust the mark schemes you see. They've not been consistent about it, and sometimes they've marked it in a way that actually isn't fully documented in the mark scheme. So there have been occasions where if you haven't mentioned an f of x, you will get no marks. Okay, the next thing we do is we look at f of 1 and f of 2. And the idea is that if this graph crosses from being positive to negative or negative to positive, then at some point in between it must have been naught. That actually depends on the function being continuous, but they don't seem to need you to say that. You can if you want to. I'll tell you how to word the conclusion in a second. Okay, but having got your f of x that must equal naught, you then put your two given values in. So f of 1 is e to the power 1 minus 2 times 1 minus 1, and we need to give the answer to that as a decimal. Okay, all we're going to care about is whether it's positive or negative, but if you don't give the value, you won't get the mark. So entering that calculation onto your calculator, we get an answer of minus 0.2817. And I need to show that value in full over here. And then we do the same thing for f of 2. So here's 2 substituted into the formula and on the calculator. Same calculation as before, but changing the 1s to 2s. And I get 2.389. So the key idea has worked. I've gone from being minus to being plus. So somewhere in between this 1 and this 2, there must be a number that makes the answer to this calculation 0. Don't know what it is yet, but I know it's between 1 and 2. So now we need to state our conclusion. And you have to do this the right way. So just learn the form of words I'm about to use and you will not go wrong. Write down something you think might be the same, but maybe not the same. You may not get the marks in the exam. Have I made that point already? So our conclusion starts, f of x changes sign. Not just the words sign change, we need to say what changes sign. We need to refer to f of x. You remember you need to have an f of x that equals naught at the start. So f of x changes sign. Next step is we need to say where it changes sign. We don't just say it changes sign between 1 and 2. Those are x values, so we need to say f of x changes sign between x equals 1 and x equals 2. And so that means that there is a root, and we give that a name. Often they ask you to use alpha, so I've called it alpha. So there is a root alpha. Say what it's a root of. It's a root of the equation f of x equals naught. So there is a root alpha of f of x equals naught with this alpha has got to be between 1 and 2. So we say 1 is less than alpha is less than 2. So there's not a huge amount in this that you actually have to learn. Okay. If you want to add to the condition that f of x is continuous, okay, it's a joined up graph, then that's really good because that's actually an important idea which they give you no credit for at all. Okay. So this is the minimal statement you need. The thing in this box, if you just, all you will ever need to change here, okay, are the numbers 1 and 2. Here and here. Otherwise, you can just recycle that same statement every time. So learn it word for word. Always use it that way, and you will be okay.